We are really happy to have everyone here. My name is Chris Skoglund. I'm the Director of Energy Transition with Clean Energy New Hampshire. Very excited to have with us today Stephan Scherer and Vaughan Woodruff. Stephan is from Craftstrom, uh, who is directly involved in the manufacturing of plug-in solar systems. And then Vaughan is a longtime partner of Clean Energy New Hampshire, who's been involved in the interconnection um, proceedings, and um, we will be hearing from them shortly. Just going to make a few notes about the presentations. We're going to go through a couple slides of introduction for Clean Energy New Hampshire, then a very brief background on Senate Bill 540. Then we're going to have our guest Stephan lead us off, and then Vaughan will follow up. We are going to try to move through relatively efficiently in order to give attendees an opportunity to ask questions. We will note that there are going to be between at least 106 and up to 250 guests that will be in attendance. So if you have questions for that half-hour period, we'd ask you to put them in the question and answer space and or the chat, and we will be curating them from there. I'll be looking while Stephan and Vaughan are talking to draw on those questions that seem to have the most repetitions throughout the chat to make sure that we're answering the questions that people have the most common interest in. We will, however, be recording this entire webinar. We will be sharing this slide deck, and Clean Energy New Hampshire will be tracking all the questions and incorporating them into an existing draft frequently asked questions deck that we have created for this. The purpose of this is to be part of a conversation that continues, and we're really happy to have two leading experts in this space with us today. For those of you that just got the invitation and are not familiar with Clean Energy New Hampshire, we consider ourselves to be the leading clean energy organization in the state with a goal to lead the energy transition and build a decarbonized energy system by 2050 in New Hampshire. We see ourselves as both advocates and educators and experts in kind of the social, political, and technical space within clean energy in New Hampshire. And where we lack expertise, we're able to turn to individuals such as Stephan and Vaughan to either speak to you directly or to guide us in the background. We have been growing considerably over the 4 years that I and almost I think everyone in the call or the staff have been with the organization. We're now up to over 650 donors with 100 businesses that are our members. But we also have 50 municipalities or local energy committees that are also our members. That's almost 450,000 New Hampshire residents that are represented by these communities, and more than a third of the state's total population. We also have all of the utilities as our members and many of the leading clean energy businesses. And we also work in close partnership with the travel and tourism industry, the Business and Industry Association, and state agencies. So we try to do our work by building trust with pretty much every sector and as many partners as we can, and then translate that into affordable, clean, reliable energy. I'd like to turn it over to our member and donor services coordinator, Annalie Preble. She's just going to give us a quick update. Annalie?
Thanks, Chris. So that's who we are and what we're working toward. Now let me show you what that looks like in action across the state. Chris, if you don't mind switching over the slide. Thank you. Clean Energy New Hampshire really reaches the span of the whole state. You can see it on the map here. We've got 650 donors, nearly 100 business members, and 50 municipalities and local energy committees engaged throughout the state. You may have even seen some of these projects around your community. So how does this work get done? Through support from people just like you. However you choose to engage with Clean Energy New Hampshire, whether it's through a donation, membership, sponsorship, or organizational partnership, you're supporting policy advocacy, technical assistance, and energy education across New Hampshire. In turn, Clean Energy New Hampshire becomes your resource for regulatory updates, webinars, templates, and networking. My contact information is right here on the screen, so please feel free to reach out anytime. I'd love to help you find the right fit with us. Now I'll pass it over to my colleague, Beth.
Hey everyone, and thank you for joining us today. If we haven't had the opportunity to connect yet, my name is Beth Sansusi. I'm the Deputy Director at Clean Energy New Hampshire. So two quick things before we proceed with the program today. First, I just wanted to say that we have the Energy Champion Award nominations are open, and these are open for 6 award categories. We've got small business, large business, elected official, community, young professional, and project of the year. The deadline to submit is September 18th, so that's coming up pretty quickly. And we'll be sure when we follow up with materials and the recording to include the links to these special nomination forms. And so next slide, please. And then want to make sure that you all know that the opportunity, the Local Energy Solutions Conference is coming up. So mark your calendars for Thursday, November 12th, and we'll be hosting at the DoubleTree in Manchester once again. It's our biggest event of the year and bringing together folks just like you who are working on clean energy projects across the state. So we hope to see you there. And then again, like I had said, and Chris had mentioned before, we'll make sure to follow up with an email with the recording, contact information, the various links and slides. So again, thank you for joining us. And now back to Chris.
Thank you, Annalee, and thank you, Beth. This is the most boring slide that I could possibly create because I wanted all the time and attention to focus on Stephan and Vaughan and your own questions. But I just want to note that today's webinar is a result of Senate Bill 540, which was signed into law, I believe in June, but it was a result of work that Senator Waters and other senators, including Senator Pearl, Avard, and others conducted over the past year. We really kind of like began the conversation with Senator Waters and others, and that helped us reach out to Bright Saver and other organizations and build the kind of understanding that was needed to create a bill that is particular to New Hampshire, and we think a great example for how these sorts of bills and these sorts of systems should be considered in the state. And so just a little bit of history. After Senator Waters and others brought this to our attention, our executive director, Sam Emmons-Brown, worked very closely with the building community, the fire marshal, particularly the Building Code Review Board, the Department of Energy, and then Vaughan through EquinoxDG, and Stephan advised us on various technical aspects. And through this, we were able to work with House and Senate members in order to develop something that had life safety and affordability kind of working hand in hand together to ensure we had the best possible systems. If anyone has more questions at another time about that legislative process, we'd be happy to talk to you. Please feel free to reach out to me. My contact will be at the end. But really want to spend most of the time talking about the systems themselves because I'm seeing them advertised every day on LinkedIn, Instagram. They're all over social media. And we want to make sure we're giving you the best and most accurate information to make sure we're using them safely in New Hampshire. So with that, I'd like to turn it over to Stephan Scherer. Stephan, if you want to introduce yourself, I think that's probably the best way to go.
Sure. Thank you very much, Chris. Hey everyone, my name's Stephan. I'm the founder of Craftstrom. I've been in the space for about 10 years now. We started the company officially in 2019. We've been certified since 2021, and we've been selling in all 50 states since then. Now, as all of you probably know, this is not a new invention in that sense. The idea of plug-in solar has been around since the 1990s, started in the United States. It used to be called guerrilla solar. It then found a new market in Europe in around 2016, 2017, when Austria, Germany, Switzerland started creating federal laws around the technology. After an important study essentially said, well, this could be like a power appliance. It is generally safe as if you keep it within limits. So that's kind of when we got started. And we started in the European market because it was ready earlier. always with the intention of bringing this technology to the United States. But it took a little further development after Europe to get there. So we were first certified in Germany and then certified in the United States afterwards. But we've been focusing wholly on the US market since 2024. So timing was fortuitous. And we're very happy to see that the market is developing slowly, that legislators are picking up this topic, and then both sides of the aisle are picking it up. It's very encouraging to see because it is a wonderful technology. Um, yeah, so I'm going to start talking very generally about the technology. And so what is plug-in solar? Plug-in solar in general is simply a non-permanent solar installation up to generally 2,400 watts. That's what the NEC kind of allows us. It is plugged into your home grid via a non-permanent connection. So typically just a receptacle, a plug, an outlet. And its purpose is to offset part of your electrical usage. You're probably not gonna offset all of it ever, but you can get to a point where you're taking out a chunk of your electricity bill. So that's generally what we're talking about today. It is way more affordable than traditional solar, currently at about half price to about a third of traditional solar. It is very simple to install. It is literally plug and play. Could I get the next slide, please? Thank you. What is it not? I'm trying to answer a few questions that we typically get also. So it is not a backup during outages. The technology requires and laws require us that these devices turn off in the case of an outage, or even if there's some irregularities in the voltage in your home. It is not like a diesel generator. It is much, much safer. We can talk about that too later. If you have any questions surrounding that, there's been some interesting papers written by OSHA and also by some other organizations. It is also, I mentioned this before, not a promise to erase your entire bill, but it is a wonderful technology to take your bills down. Next slide, please. So, how much can you save? Well, typically, as with all solar, it really depends on where you're located, how you kind of turn the panels towards the sun, what season it is, and something that we always try to educate our customers about is shading. Shading is horrible for any solar panel. You do not want any shading. You want to get the maximum out. You want those panels to live as long as possible. So ensure that you always get full sun. And then even in New Hampshire, don't have to be in California, don't have to be in Florida. Even in New Hampshire, you can produce, up to 3.6 kilowatt hours of electricity for your home in a day with an 800 watt system, which isn't even the largest size mentioned in the current law. So payment time, payoff time, again, depends on your electricity price, how much you're actually producing. That'll depend on your location, etc., as I mentioned. But you can typically pay these systems off in between 2 and 6 years, anywhere in the United States. Next slide, please. Thank you very much. So how does it work? It works very similar, and it uses mostly components that are used in traditional solar too. Microinverters are not inherently just for plug-in solar. They're used in traditional solar roof installations as well. So you start out with some solar panels. They produce DC power. Our appliances don't use DC, so we have to convert that to AC. That's what the microinverter does. But, and we'll talk about that too, microinverters at this point are highly efficient, highly intelligent products that do way more. They also actually protect your home uh, from any sort of overloads, from anything that's happening in the grid, and protect also line workers, which is a very important point. You always get also cablings, any sort of safety devices that you required. And then typically you also need, according to the NEC, something that protects your home, which in our case is a power meter. So we always mention that as well. And I'll get into that in a few slides. Can I get the next slide, please? So now we're going a little bit into what happens in a grid, and you don't have to focus too much on this illustration, but essentially, I want to explain that to kind of explain that also another limitation of plug-in solar. typically in your home, you will get from a transformer outdoors two main cables, leg one and leg two. They will carry 120 volts each. You use 120 volts. Some devices like a dryer might use both, then you get 240, but we're focusing right now on typical branch circuits, right? So that's a typical branch circuit. It goes from your breaker box to outlets to lighting in the kitchen. You might also have your microwave plugged into one, um, your fridge, etc. So you're trying to offset those typical appliances, fridges, lights, TVs, computers. If the system is large enough, maybe even a microwave. But you can always, and that's where the limitation is, always offset only one of these legs, and we call those phases. So you have a split phase system in the United States, each 120 volts. And typically, when you plug your system into a branch circuit, it will supply all breakers on that one circuit, on that one phase. So you can offset at least half of all of your users. There is, of course, a possibility to plug in a second system on the second phase, which helps you if you're running ACs, for instance, you want to offset more of the AC, because the AC typically runs on both of these phases. But it's a very important point to make that power doesn't jump between phases. And there's very few cases where the utility meter from the utility will actually help you. Most utilities do not. So when you power something, you have to think about where you want to plug it in, what you want to offset, where are your heavy users that you use daily, day in, day out. Now, something to consider, and that's where the NEC comes into play, is how do we keep that circuit safe that you plugged into? And the NEC has a very particular topic here that they focus on for a good reason, and that's breaker masking. If you could please get to the next slide. Thank you very much. Oops, no, yeah, perfect. Yeah. So I've put in two cases how you could run a system. One is not safe, one is safe. And we're not even talking about here using like a power meter to protect the circuit or anything. This is generally how you could run them. And as you can see in the top picture, um, we have appliances, in this case, hair dryers, plugged in after, literally physically after the plug-in system or plug-in battery in this case also, which means that you're pulling power from the grid to power those devices, those appliances, and at the same time, you're also supplying power through your plug-in system. And here the NEC says there is a case where you could be overloading this small subsection of that wiring by simply pushing power where we're already pulling power, therefore overloading the wire. And the thing is, the breaker only measures in one direction, so it will not necessarily know that a fault is happening. And that's called breaker masking, when it doesn't see kind of what's happening 100%. So the NEC says, well, in theory, if you plug it in correctly, as that's the low, and as in the lower picture, that risk is gone essentially. But you cannot ask from your everyday consumer to know this, or frankly, in my experience, even from electricians, that they know exactly which outlet is where on a branch circuit. So the NEC says, well, in that case, there's two solutions for you. One is written here or emphasized here. You have a power meter. That power meter allows you to measure exactly the usage on that circuit. Power meters are typically simple devices. They have come with these clamps. We call them CT clamps, current transformer clamps. They measure the amperage through a wire. You click those around the wire. That information is then reported to, for instance, the inverters. And there's a very simple algorithm that ensures that the total power that you're using plus total power that you're producing together, summarized, do not overload the circuit. So that means, in essence, you might have to reduce your solar output to ensure that you cannot overload your circuit. That's what the NEC wants. Or, and if you could please get to the next slide, you have a dedicated circuit. And that dedicated circuit simply means you go from a breaker, a single wire, a single circuit essentially, to one outlet. That is not a common occurrence in most homes these days, which is why, for instance, we as a company generally sell our systems with power meters. You can't really ensure that. If you know for sure, absolutely, the NEC says you can run a system on a 20 amp breaker up to 2,400 watts. That then gets reduced again if the NEC likes to say, well, if you're running this, excuse me, longer than 3 hours, you might still degrade the wiring, so you have to reduce it to 80% of those 2,400, which is where we get this strange number, 1,920 watts in some other states, like Colorado, as a maximum system size. Yeah. So to summarize again, you either have a dedicated circuit, which, you can also do. You can call your electrician and say, give me one outlet direct to a breaker on phase one, for instance, because I have a lot of users there. And then you can plug in your solar system there, and it'll be completely safe. But you still only have you only have to consider the wire thickness essentially. Yeah. Or if you don't know, use a power meter. Thank you. So, the idea to keep this safe, it's a process essentially, right? And we want to be able for consumers and legislators to know that if something has a certification that is absolutely safe, that it's been not just certified, it's been tested in a lab to certain conditions, right? And how does that evolve essentially? So it starts with the National Fire Protection Association, the NFPA. They essentially write the NEC, the National Electric Code. And the National Electric Code gives us the rules on how to make something safe, how to run something in a safe way so we don't burn our houses down. It's not federal law, so it can't be enforced by the NEC itself. It is basically adopted by the states and then enforced by the states, which, by the way, is why some states create these safe harbor tiers up to 400 watts without any considerations of a power meter or safety plugs or anything, because they're saying, well, we're the ones enforcing the NEC, so we can make exemptions. Again, Colorado comes to mind. Those safety needs are then translated by, for instance, UL, Underwriters Laboratory, who then create testing regimes. You have to follow this as a company. So we send our products, 10 inverters to UL. We say we want, for instance, UL 1741 certification for this inverter. They will tell us, okay, send us your 10 inverters. It'll take X amount of months. It'll take probably cost 100 grand or so. And then what you get back, and you work with them, right? So it's a process. If they find a fault or something, it's not simply returned. They say, okay, you fix this, and then so on. It's an iterative process. But over time, you get these super products that have been tested to all weird niche cases. Our German version, for instance, our inverter doesn't interfere with ham radios because that's a requirement in Germany. So it's UL that basically tells us how to ensure that these are safe, how to test them. They test them for us. And then we get a UL, or in our case, for instance, ETL from Intertek label with a number that someone can look up and see, okay, this product is now safe. That's what customers, lawmakers, etc., rely on. And they can do so as I will present in a few minutes now. Now let's talk a little bit about the standards that apply to these systems. You probably all have heard of UL 3700. On the next slide, please. Thank you. UL 3700 is a fairly new testing standard. It was first published December 11th, 25 or so. As of January this year, we can certify to it. It is a first outline. But what we really need to discuss is that it's at this point, not just an outline, it's an umbrella certification. It touches upon subjects that are typically not dealt with in other standards. But before we get to UL 3700, every manufacturer has to go through various other safety certifications that are not being replaced by this. So I mentioned UL 1741. That's in combination with IEEE 1547. That's mentioned here on the second from bottom line. That's probably the most important one that everyone discusses because we always hear, but what about line worker safety? This is the standard that tests how quickly an inverter can shut off in case of an outage. Yeah. It's one of many things, it's one of many certifications, but this is the most important one. Um, at the moment, for instance, it still says it needs to shut off in 2 seconds. That's very long for our purpose. And because of our inverters having been certified to German standards and discussions also with UL, I mean, at this point, industry standard is that everything shuts off in less than a second, as quickly as 0.2 seconds. That's not just for line worker safety, it's also for consumer safety. Because as you can imagine, we're selling direct to consumer, so it's very important to us to sell products that are ultimately safe, which means that in this case, you can unplug it and touch the prongs and it's completely safe. Nothing's going to happen. So that's one of those certifications. Then there is another one. I mentioned the power meter before that works in tandem with the inverter. UL 3141, for instance, is a standard that tests power control systems. That essentially just means that the inverter and the power meter talk to each other, and if the power meter says, well, there's too much power pumping through that circuit right now, throttle your output. Yeah. So that's test. So you already have a test between two products, right? And now we needed a standard that covers everything else, safety plugs and receptacles, GFCI. This is a very interesting topic because the requirement is essentially a bidirectional GFCI for this. Funny thing is, it doesn't exist yet. No one's ever developed one. It wasn't necessary so far. So this is a fairly new requirement. So we're all kind of developing now new technology again to adhere to this standard. Um, it also touches on UL 3141 to ensure your grid safety, essentially your home grid safety, and then stuff like labeling as well. So it's, like I said, it's an umbrella certification that doesn't replace any of the old certifications. It just adds onto everything. And typically, it's also not seen as a blanket permission slip for all states. Yeah, so that's why legislation is also very helpful. But at the same time, my main message here would be legislation is typically not used to regulate safety, right? So what we're doing with legislation, which is why we're also helping with legislation in various states, is because you're getting rid of other market barriers, such as the requirement for interconnection agreements. That's a big one that we're trying to get rid of essentially with those laws. Um, and So the final question is, I guess in most people's minds, is this inherently safe? Can this be sold in the open market to any consumer over the counter, essentially, to eventually, picking one up at Costco, for instance? Is it safe enough for that? Could you please get to the next slide? Unsurprisingly, yes, that's my opinion. But it's not just my opinion. It's these in microinverters have been extensively tested to rigorous standards. OSHA itself says the risk is negligible to anyone using them. There was a magazine, Incident Prevention, that says they're virtually 100% safe. The risk is 1,000 times less than getting hit by lightning. Um, and don't forget, these products have been in development for decades. Like microinverters are not something new in principle. What, for instance, companies like we did is we tried to make them more useful to the end consumer directly and sidestepping the installer, which is why we integrated Wi-Fi for the first time in our inverters in 2018 or so. Um, uh, there's just there's 5 million systems of these installed in Germany alone at this point. We know they're safe. There hasn't been a single incident where someone followed the manual and plugged it in correctly. I think I can think of one incident where a battery inverter started smoking or something like that, but virtually for inverters, it's absolutely safe to be used by the end consumer. And that's where I'd like to end my presentation and hand off to Vaughan, who I love and talk to because he's an absolute expert in this matter, and enjoy. Thank you.
Thanks, Stefan. Awesome. Well, glad to have everybody here. I'm going to be quite quick. What I really want to look at is the consumer safety side of this. Could you go to the next slide? Just a quick background on my perspective in this. I make no money off of plug-in solar. I actually think I lose money off of plug-in solar these days because I have friends like Chris, I think may have compromising photos of me from back in my 20s. And so I help out with these things where I can. But just for a little bit of background, I've been in the industry for roughly 20 years. I had a solar contracting firm that merged with a company many of you probably know in New Hampshire, which is Revision Energy back in 2021. Um, I chaired the industry trade group in the state of Maine. I've been in the industry since before it was mainstream, back when we first talked about it as alternative energy. And what's really exciting about plug-in solars is kind of catching the energy that we had 15 or so years ago when we started to see rooftop solar become more accessible to everybody. Um, and there are lessons from that time that I think can be very helpful in terms of when a technology is new, we really need to have a high bar for it so that it establishes a good reputation and the market picks up. So why don't we go ahead to the next slide? And I'm just going to do this from like a buyer's perspective of saying, okay, if I'm buying a traditional residential solar project, what's happening behind the scenes? Go ahead and click next. So this is a design that would happen, and this design needs to comply with the state electrical code. In the state of New Hampshire, that's the National Electrical Code. Go ahead and click again. And by having these designs, you'll see that this will check on a few things. One, that the module is listed, the inverter is listed. Go ahead and keep clicking, and I'll go through each one of these. That the equipment is properly grounded, that the wires run between the solar panels and the inverter are the right size, the ones between the inverter and the main panel are the right size, that the panel is the right size, right? Like these are all of the details that take place. And as a buyer, you don't have to worry about this unless you're doing it yourself, right? Most of the solar that gets put in New Hampshire for rooftop, they hire a company, and it's the company's job to deal with this, to make sure it complies with the National Electrical Code. And there's an electrician who's in charge of supervising the installation to make sure it complies as well. And in many jurisdictions, there's an inspector who comes in after the fact. Go ahead, next slide. Now, one of the things that the New Hampshire bill did is exempt these systems from the interconnection process. And this is the utility approving a project. This is the world I live in. My consulting firm focuses specifically on interconnection challenges around the country and trying to streamline it. The interconnection process isn't meant to be consumer protection, but it provides some invisible consumer protection, right? For instance, when the utility reviews the project, they're looking to make sure that the equipment is listed to the safety standards that Stefan had mentioned. When construction takes place, it's with folks who understand the electrical consequences of the project. When inspection takes place, right, the code inspector comes in and says, I attest that this has been installed in that manner. And then a last piece here is that when the project's given permission to operate, the utility knows whether the meter is set up to be able to handle what's going to happen for this house now that a new solar project's in. Next slide. And then we come to plug-in solar, which part of the exciting piece of this is that it removes some of the expensive components like building, one-off building plans, electricians needing to be there, permitting, et cetera, et cetera. But the same safety considerations still need to be addressed here, right? So go ahead and click. You just click through these until you get to the plug. So, the module listing, the inverter listing, the conductor sizing, the equipment grounding, the maximum voltage, right? These are all things that need to be taken into account if we're going to make sure that things are safe. And the question becomes, if you're a consumer and you don't have a company who's going in and taking care of these details, how do you best manage that? Go ahead and hit the next one. And you can stop right there. The other big question of this is that you as a homeowner, if you're buying one of these systems, are the person who's plugging into the outlet. Now, everything downstream, the module, the inverter, the wiring, all of that stuff could be safe, but that's built in in some production factory. Your electrical system wasn't built in a production factory, right? So there's also what happens at your house. Go ahead and hit the next slide, please. So one of the things, and this got brought up in the Q&A, this is one of the safety considerations when someone's putting in a rooftop PV system. Click, please. Let's say, for instance, that all the loads in the house, go back one, please. That's fine. So let's say that orange arrow is like the loads in the house. Let's say you're running a ton of stuff and you draw 100, you need 115 amps to run your appliances. The way that I think about it that makes sense in my brain is I'm trying to draw that so the utility needs to push, right, that power so that it can supply that appliance. So in this case, if I have 115 amps, it's being drawn out of my service panel, which isn't likely to happen most of the time, but could. And the utility delivers 115 amps. If my panel is only rated at 100 amps, you can go ahead and click now. I have a main breaker in my service panel, right? That's going to open up to disconnect the power so that the service panel is not damaged, that any of the downstream stuff's not damaged, and even the wiring from this panel to the utility is not damaged. Next. Now let's go ahead. Yep, through that. Now let's say, for instance, stop right there. We have that 115 amp load, and we have a rooftop solar system that's pushing 15 amps into the panel. Now the draw that's asked for from the utility, go ahead and click, is 100 amps. And because that doesn't exceed 100 amps, it's not going to open up the main breaker, which means we're going to be putting 115 amps through a 100 amp panel. This happens all the time because what the code specifies, and I think it was noted in the Q&A, as long as the source from the solar is at the opposite end of the panel as the source from the utility, we're not going to get overheating. It's going to be distributed in the way that the loads go through, right? Things are going to be safe. Next slide, please. Now, the question becomes, if you put that 15 amps up towards the top of the panel, you will have overheating in this kind of condition. And so that's why the code requires the breaker being in a specific position. And much as Stephan said, like, a lot of times folks don't know if the plug is the only plug on a circuit. They don't know where, I mean, do you know where your outdoor, do you know where your outdoor outlet comes into your panel? Probably not. And there's a strong likelihood that it's not where it would need to be from a safety perspective if this has to meet, right, the National Electrical Code and its strict interpretation today. Next slide, please. And then I won't go too much into detail, but there's looks like the formatting screwed up a little bit. There's a QR code here. UL has like a safety document that talks about all the things that it's thinking about under that UL 3700 listing. But the breaker masking is the same kind of idea. So Stephan noted here, if you've got 20 amps off of a 15 amp circuit here, things will heat up and the circuit will open up because the circuit breaker will open up and everything's protected. Next slide. And this is the instance that Stephan showed. If that PV source is between the circuit breaker and the load, you can see that 20 amps on those wires would exceed what's there without the breaker opening. So these are some of the considerations that folks are trying to figure out. Next slide, please. So let's go back to this system. So yeah, you can go ahead and click through. There are going to be a few more things. Like these are the things that need to be figured out here, right? Which are, all right, we get an appliance. Is that safe? We'll talk about that in a minute. Is the wiring safe to accept it? Go ahead, next. Click again. So there's a listing for modules. Go ahead and click again. A listing for inverters, right? So two separate components. Stephan talked about that. But like the wiring and everything in between isn't really taken care of except for this UL 3700 listing, right? And then the question is, well, what about the plug? And as Stephan talked about, go ahead and click again. The UL 3700, one more time, is intended to cover this whole thing. So that's why UL 3700 is such a big consideration, because if you're not buying it from a contractor who's putting all of this stuff in, how do you know it's safe all the way from the PV module right to the service panel? Next slide. Go ahead and click through for the labels here. And then this last one, one back. This meter configuration one's an important one as well, right? In New Hampshire, so first off, these three question marks about the breaker and the panel and the conductors, UL 37 is intended to address that as well. But one thing that's a challenge here is the meter configuration. So the types of meters that a lot of New Hampshire customers are served by doesn't measure the direction that power flows, it just measures the power flow. And so if you're exporting power to the grid, it will read those types of meters will read it as consumption. So you'll be paying for the power that you're putting onto the grid even and not getting compensated for it. So these are just things to be thinking about as you're going through and figuring out as a buyer how to manage these risks. Next step. Next slide, please. So this bill, and I'm sure we'll talk about a little bit, is meant to be enacted in January 2027. I think the hope is that UL 3700 products will be on the market by that time, right? And then you can, if you want to ensure safety, like if you want to do what the codes would tell you to do, it's buy that UL 3700 device once it's listed and once this law goes into impact. If you want to avoid utility overbilling, the best thing to do there is use power during the day. You could put in a plug-in battery, right? So that you can be charging the battery and maybe it's plugged into a refrigerator or something else along those lines. Or install a power meter, right? And a power meter can help to regulate this and make sure things don't go back to the utility. The last one, I say 1 and 2 there as like, here's what should be done by the letter of the law. The reality is people were buying these before the legislation even was written, right? And people are going to be doing this. And people have always done this with solar in its early infancy, is to like push the boundaries with it. It's one thing to push the boundaries when you know what you're doing, right? Because you're going to be you potentially the one who are going to be dealing with the consequences. It's just make sure you're doing your homework. If you're just buying some device off Amazon or LinkedIn or whatever, Instagram or whatever the kids use these days, right? Like if you're just buying that, you don't know the listing, you don't know this, you don't know that, and you're just plugging in an outdoor outlet, you are taking on the responsibility of that risk. And so it's really great that organizations like CNH are working right now to try and help get this information out to make sure that folks know what they're getting into, right? So that's my 2 cents on this, and I'm really excited to see how this takes off and hope that we hear stories of great success from the use of this technology, and don't see ones of houses that burn down because of it. So.
Thank you so much, Vaughan and Stefan. That was great and fantastic. Just in case anyone drops in the next few minutes, noting that there are ways you can contact Vaughan and Stefan. If you have New Hampshire specific questions, I encourage you to reach out to me directly. But just quickly looking at some of the questions that we are getting, I think one of the ones that just kind of distilling off is, so what you're saying is we cannot just go out and plug anything in that we find online or in a store right now.
I mean,
That...
you can. There's lots of things you can do, Chris.
Yes, exactly. So you can, but if it's not registered for UL 3700, what would be the risks to a homeowner or a renter if there were to be some issue that popped up?
You want me? I'll be happy to take care. I mean, there's the potential, there could be high voltage that happens. I know like Craftstrom takes into account like what are the voltages and the wiring out of the panels, and they're in that safe touch region. You could see high voltages there. You could see inverters that come in that aren't anti-islanding, which is that UL 1741 listing, and could power back. And I think like you could put something big in an outlet that can't handle it in an old house. That's the biggest risk, I think, is just that like the potential to overheat conductors in places you can't see them, and overheated conductors can turn into fire.
Great. I think one other question I just want to note is, or ask before we dig a little bit more into other questions, is a lot of the media and attention has been that Germany, I think largely since the Ukraine invasion, has installed nearly 3 million of these systems. And the story that I hear often is that they are just really plug and play, and there's not as much of this concern about safety. What is significantly different about the German system that makes us have to be a little bit more cautious in how we roll out these systems? The easiest way to describe it, either Stefan or Vaughan.
I mean, yeah, just because I've dealt in that market, um, the systems are simpler because they're, well, not smaller, but essentially we in Germany they use 230 volts, right? And when we're talking about wiring safety, we're talking about amps. So what's the current that's flowing through the wiring? Um, because they're using 230 volts, the current is halved compared to the United States. So when people hear, oh, okay, in Germany we can plug in 800 watts, the equivalent to that in the United States is 400 watts. So essentially what they're saying is you can plug in up to 800 watts anywhere because the amps that this system will output will fall within the safety buffer of the wiring. That's why some states are doing the same thing, like Maryland and Colorado, and creating the safe harbor tier, which is up to, I think, 391 is the 3 amps. Um, but as soon as you want to go over that, you also need either a battery or a power meter. So the same safety considerations apply. It's just that because of the higher voltage, you can essentially plug in double the size of the system to be safe.
All right, great, thank you. Um, Another question is, if we were to have these systems and plug them in, how many systems uh, could we legally or safely plug into a home?
I mean, Vaughn, I mean, in honesty, the NEC gives us guidelines of how much you can plug into an outlet through a branch circuit. Um, what's limiting in these laws right now is that we're mixing up multiple questions and trying to find one value that'll satisfy both. Um, both of these main topics. One is like what's safe to plug in, and the other one is how much does the utility acknowledge can be exported if you're not using any of the power, right? And that's how we get to the 1200. Um, in my mind, an optimal system, as I said, would be plugged in one in each phase. With regards to the law, you can also split a 1200 watt system into 600 each and then plug one each into one phase, and it would still be it would still adhere to the rules in the law. On the other hand, in draft legislation that we're working on and working in a couple of states to change it also, we're trying to get that limit up a little bit, at least with regards to how much you're putting into your home. Right? So we have to differentiate between those questions.
Yeah, great. And just for people that have not spent as much time in looking at their circuit breaker, the two legs, if you open your circuit breaker, you'll have one side of the panel and another side. Each of those is a leg that's coming into your house. And sorry. The next question is, there are a lot of questions. And for those of you that joined late, we will not be able to answer all these questions. We are going to record them and we are going to put out an FAQ. It will not be static. We will update it because this continues to be a living and breathing process. But in terms of UL 3700, which shows that it's almost an ecosystem of approvals, when do we expect that might be completed so that we would have systems that qualify?
Yeah. Say early next year, probably. Like I said, there's still a few things that we need to iron out. Um, And then it's a still evolving process within UL to get that standard to where it needs to be. So UL has technical committees. Those technical committees are staffed by company engineers, other experts, etc. And then they discuss that standard as it evolves, and then after 5 or 6 years, you've got a fully fledged testing standard. So it'll take a couple of years to finalize it. It's very much a guideline still. Nothing is super concrete in there. So we have a lot of leeway during the certification still. You might have seen that Hoymals and AP Systems have called their inverters UL 3700 compliant. Yeah, I mean, in that sense, most inverters are compliant. In order to have a full certification, you need the bidirectional GFCI, you need the power meters, and these companies haven't finished that process. So
Yep.
it's going to take some time to develop the additional products, the additional safety features that are required. And then there's going to be a lot of discussions too. I mean, we had the same discussions in Germany with regards to, do we need a separate outlet, like a lockable outlet, to ensure that people are safe, that the whole system is touch safe, etc. We're going to have the same discussions here in the United States, whether that's really necessary or not, or whether there's other solutions that are simpler that do not create an extra barrier for the consumer. Because you imagine, it's not plug and play if you then need to call an electrician also to exchange one of the outlets with a safety outlet. So there's going to be a lot of discussions, and yeah, I'm in technical committee for UL 1741, and I just applied for the 3700 too. So wish me luck.
All right. Well, definitely good luck. So I think what sorry. Um, what I I'm just going to work my way through it. What I think is important that I'm understanding from the conversation is there's a lot of excitement about plug-in solar. There's a lot of advertisement that is on social media. There are high energy prices that increase the pressures on people to find solutions. But what I'm hearing is that the technology exists, but the certification has not yet been put together to ensure a fully safe qualifying system is yet ready to be on the market. And so for consumers, homeowners, that are looking to take advantage of this technology, we do have a little bit of a wait ahead of us if they're going to do it safely and in compliance with the law. Is that a fair assessment?
I mean, yeah, if with regards to plug safety, again, it's nothing that's never been discussed. That's why on all these inverters, there, I've got one right here. All these plugs are essentially those safety plugs people are discussing, because there's nothing new under the sun, as you can imagine, with regards to plug-in inverters. Um, we've been selling in all 50 states for the past couple of years already under existing certifications. We've never had an incident. They're perfectly safe. But yes, as UL 3700 now evolves, we are getting the certification. And then if you want to wait for that, absolutely. From our point of view, everything that's being considered, we have considered already. And we've certified to, what is possible, essentially, at this point. But you're very welcome as a consumer to wait until everything's fleshed out and UL 3700. And companies like us have UL 3700. It will take a little bit of time, but it's not going to be an endless process.
Um, I am seeing that Mike Hagan, who is the building code official from the city of Keene and a strong ally in this space, is just noting that these systems do need to be installed in accordance with the state building code. And so when UL 3700 is complete, it is my understanding that the Building Code Review Board will be part of that adoption process to make sure that it is that the codes are established. And I think that then goes to a point that Vaughan was making, and I realize we're coming up on time and the number of questions is probably only greater now, is the way that we are looking at this. Vaughan recommended that we do research. Is the average homeowner at this point, when the UL 3700 comes out and it's incorporated into the building code, is this something that even though an average homeowner could pull an electrical permit, is this something that you would feel that the average homeowner could do, or it is really something that we should be deferring to professionals in most cases that are going to be electricians that will have time to kind of study this and make sure that it is at the end of the circuits and that there isn't overloading? Or is this something that is really seen as something an average homeowner could do on their own or a renter could do on their own?
The renter homeowner is a very different set of
Yes.
really set of discussions, right? Because especially with the UL 3700, if there needs to be an update to the outlet, right? Like, is an electrician coming in? Is a tenant being allowed by their property owner to swap out an electric outlet? I think there's been a big push of this for renters. The legislation that I've seen passed nationally in the direction that it's in right now isn't really towards renters. A lot of it's really towards homeowners in a variety of places. I mean, there may be things to do, but UL 3700 requiring the outlet definition that it does is going to really preclude a lot of renters, I think, from this. As it relates to overall, I mean, one of my recommendations to some of the national advocacy groups is to think about this in phases. I know there are a lot of organizations that are probably attending here today. I think there's a lot of benefit in thinking about it like the old Solarize programs were, right? Where you try and have folks get together to overcome some of these initial hurdles. And so if you want to have a group that's coordinating these and bring an electrician in to make sure that the first swath goes in, that could be a really effective way to scale this and get used to this technology, especially with all the parties who are at the table between, code officials and legislators and everything else that's there. I think some of this could free up. I mean, Stephan can talk more about what happened in Europe, but I think some of the effort that was there and done with the thoughtfulness about how the electrical system worked is what actually helped push change. So,
Yeah. I mean, like I said, we had the same discussion, especially with regards to safety plugs in Germany, and it was dropped as a requirement eventually because it was seen as a barrier and the market wasn't accepting it. So we also have to be aware that regulations say one thing and then the market might follow another route. That does happen every now and then. It happened in the German market and it could happen here too, that people just go online and they go to Timo and buy a regular outlet, sorry, a regular plug, because these safety plugs, they're standardized. So you can find all these cables in all variations essentially. So I'd rather have an ongoing discussion on how we can solve this problem without creating more barriers with this UL 3700. But we'll see how it evolves. And as a company, I can say we'll just adapt. It's not an issue really. Um, that's the whole point, and we're innovating to make this as simple as possible. And with new regulations comes new innovations.
All right, we are at time. I want to just be respectful of Stephan and Vaughan's commitment to us. We are tracking all of these questions. The webinar is recorded. I understand that we have only begun to scratch the surface of the questions you have. And so if you do have questions, please reach out to me at chris@cleanenergynewhampshire.org. We have a FAQ deck that is ready to go, or was ready to go, but in light of all these questions, there is more that we will be adding before we publish that. But we'd like to get it out in short to address questions that we didn't cover, like how do we integrate batteries? How do we integrate this into systems that have already on rooftops? Where can it be placed optimally on a house? And what might be electricians or installers that would be recommended. So there'll be very broad answers to these, but this continues to be cutting edge, and we are very excited about opening and making more affordable and accessible clean energy solutions. But we want to make sure we're doing it in a safe way that balances that affordability with life safety. So it does feel like I'm cutting us all short, but I want to thank you all for your time. Please continue to engage. And if this feels like something that we should continue to invest, please also let me know. But thank you again. Thank you to Stephan and Vaughan. Really appreciate your work over the past year to help New Hampshire put forward something that does increase access while doing it safely. And also thank you to our partners like Mike Hagan and the Building Code Review Board and the utilities themselves who helped make this an understandable and workable process. And we hope to do more of that in the future. So thank you all so